Question 2, tutorial 2. In the arrangement shown, determine the speed which the circular cylinder would fall when steady state has been reached. The cylinder is made of steel with a density 8,000 kg per meter cube, and the oil has a viscosity of 0.6 Newton second per meter square. Okay, so it's a needle pull down with a constant velocity v. The density of the steel is 8,000 kilogram meter cube. Okay, and the viscosity of oil viscosity of oil is equal to 0.6 Newton second per meter square. Okay, when the steady state is achieved in this arrangement, it means the force is balanced. It means downward force equal to upward force. Okay, and the downward force in this case we have is the weight of the circular cylinder, and the upward force in this case is shear force. Shear force. Fs in this case is shear force. Okay, so we will have the weight equal to shear force with the weight of cylinder will be equal to rho gravity and volume, with rho gravity volume of the cylinder is similar to question 1, pi d square over 4 times L. Okay, with d is this one, the diameter of the cylinder, the length of the cylinder. Okay, and we call this one the distance between the wall to wall is d1. d1 is 150 millimeter, and the diameter of the cylinder is 149.8 millimeter. Okay, this one is weight. So shear force in the tutorial one and in the lecture one, you know that the shear force is equal to shear stress times area. Shear stress times area. Area in this case is the contact area between the cylinder and the oil. Okay, so the area here will be equal to pi d times L is a outside area of the cylinder. Okay, outside area of the cylinder. With shear stress, we have equation to find shear stress will be equal to viscosity times delta V over delta, in this case delta D or delta R. Okay, which delta V is a velocity, the difference in velocity between the cylinder and the wall. With delta V here will be equal to delta V equal to V of the cylinder minus V of the wall, and the cylinder move with the velocity V. V of wall is 0, so it's 1 equal to V, velocity of the cylinder. Delta R is a distance between the cylinder and the wall. This one is delta R. Okay, so delta R will be equal to D1 minus D over 2. Okay, D1 minus over 2. So in this case, will have shear stress Fs will be equal to viscosity times V divided by d1 over d divided by 2 times pi dl. Okay, pi dl. So when we apply to equation 1, also is it not equation 1 here? This equation, we will have rho of steel, this rho steel, gravity pi d square over 4 times L equal to viscosity V divided by d1 minus d over 2 times pi dl. Pi dl. Okay. With the density, this one is 8,000 kilogram meter cube is given. This one is 9.81. Gravity d diameter of the cylinder is 149.8 millimeter or 0.1498 meter. Converts to SI unit. The length is 200 millimeter or 0.2 meter. Okay. Viscosity, oil viscosity, we have 0.6 Newton second per meter square. Okay. D1, we have 150 millimeter or 0.15 meter. D 0.1498 meter. Okay. The diameter D 0.1498 meter. Length 0.2 meter. So from one equation we can, and we only have one variable is velocity v. Okay, so from this one we can find v is 0.49 meters per second. Okay, it means the cylinder will fall down with the constant velocity is 0.49 meters per second.